Hi, my name's Peter Koutsoukis and I'm going to be teaching the CET236 Summer 2021 session that's going to start shortly. And I thought I'd just give a brief introduction to what's going to happen. So you can review all of this stuff in more detail, either in the syllabus or in Blackboard generally. The syllabus is available in Blackboard. So the first part, that's me. I'm Peter Koutsoukis. I have degrees in electrical and systems engineering. That's my email address. I'm not on campus, as you're aware. This is an online only course. So if you need to talk to me directly, please use that booking link to book a general consultation. I only have availability, I think I set it up for Tuesdays, Wednesdays and Thursdays afternoon and evenings. If you can't see me on any of those times, please let me know and I'll see if there's another time we can meet. I'm assuming you're from one of the backgrounds at the bottom, right? Mechanical engineering technology, computer engineering technology, robotics, mechatronics, and I think I also saw somebody from manufacturing as well. Okay, so this session. So that's what we've got to get through. I'm starting on the Monday after the first week, so I think the session officially starts on a Tuesday, so we missed the first Sunday to Saturday week of the session, but that's okay. This session is a little short, so you are going to have to spend a little bit more time than maybe you would during a normal session on this course, but not too much. This is a list of the topics. The topics down in the bottom right are things that we would do if we were able to get into the lab. What I'm going to try and do is do a video of me using a multimeter, using a power supply, using a function generator and using an oscilloscope. It's not quite the same thing as you getting used to using those things, but we'll do our best. This is just an overview of the textbook chapters and the pieces that we look at in the textbook. The textbook is not required. You should be able to get through this course without having it, but if you need backup, if the things I'm going to talk about and we're going to do in class aren't enough for you, I highly recommend it, because I'm pulling everything out of this textbook. In this diagram, the cloud indicated chapters are chapters that I either don't use anything of, which is the red ones, or only use a little bit of, which is the blue ones. Everything else we should be able to cover, and the topic number is indicated in the bigger numbers. That's the textbook, Introduction to Electric Circuits by Dorf and Svoboda. If you want to get it, I think it should be available in the bookstore. So this is online. I have a series of videos available, so please, when I send out the weekly email with the work ahead, please look at the videos. Each week we're going to have to do look at the video. The Monday evening classes, I'm going to sit through and watch the videos with you. I'll pause the videos periodically and make comments about them and ask questions and take questions, trying to answer your questions, and we'll see how we go. The assessment, there are labs. These are all simulated using LTSpice. LTSpice is a freely available piece of software for analog devices. It's pretty much industry standard, so I suggest you download it and install it. You can also access it on the SEST Citrix server if you don't want to install it on your machine. Homework is all going to be done using Webwork. If you go into Blackboard, there's instructions about how to access Webwork there. The tutorials are going to be done a little differently. They're questions that I want you to answer, and you don't have to answer all of them, just one per topic. And then I'm going to get you to review the answers of the other students in the class. I find that doing that helps you understand what other people, the way other people think about the problems. And the aim is that the grade you get for the tutorials is for you A, submitting something for each tutorial, and B, participating in the review of your peers. If you do both of those things for the tutorials, then you will get 100%. I am probably also going to give a bonus over and above what's on this list for the grade you get for those tutorials. So the main thing with the tutorial is participation. I do all of my exams, both midterms and oral and finals, as an oral exam. So you'll get used to doing those. I've got some examples in this slide deck that I'm just going to briefly go through to show you what sort of thing is available. Here is what LTSpice looks like. This is what LTSpice looks like on a Mac. Again, LTSpice is available on the CEST desktop through the Citrix server at Central. So if you don't want to install it, please just run it under Windows. Windows looks a little different. It's got more buttons, more icons, and but it runs both on Mac and under Windows. This is what Webwork looks like. And there are 8 pieces of homework, and the homeworks will become available at midnight on June 1st. So I suggest you do the fundamentals one first and then move on to the KVL, KCL dividers one. This is the first tutorial. I actually need to go back and edit it a bit, the questions, where there's probably too many questions, but have a look at it. And once it becomes available, again, it'll become available on June 1st at midnight. This is an example of the sorts of questions you might see on the midterm. What I usually do is for each topic, in this case there are 3 topics on here: charge, resistivity, and then resistance versus temperature. I usually give 3 or 4 questions about each topic, and then while we're on the call, I ask you to answer 1 question per topic. So you don't have to answer all of them. It helps if you can, but I will ask you only 1 question. And then the other part of the midterm is mesh analysis and nodal analysis. And again, this one there's only 2, so it's maybe a little easier. This is part of the final, and the topics are about impedance, which is a little different from resistance, which we'll talk about soon. There's using phasors and superposition, which we should know about eventually. There's looking at transients. There's looking at Thevenin equivalent circuits, and there's looking at Norton equivalent circuits and source conversions to convert between Thevenin and Norton equivalents. That's it. I hope to see you on Discord shortly. So welcome. If you have any questions, please either email me, ping me on Discord, or yeah, you can call me too, but I tend not to answer calls unless I know the number, so text me that you're going to call me first if that's the way you're going to contact me. Email and Discord, much preferred.